Hello students. The previous class was a bit at the last and was not good because there was a power outage. So, today let us continue from that point. So, we were learning about capacitance. Okay, we were learning about capacitance. So, now we shall be learning about a capacitor. Okay, we shall be learning about a capacitor. So, capacitor capacitor or it is also called a condenser. It is also called a condenser. So you should have heard about a capacitor or a condenser at your home very often. Okay, these things are used in fans. In fans these things are used, and even when if you bring out a capacitor from a fan which was used some moments ago, and you bring down a fan and just screw out that capacitor, when you touch those wires you will feel some shock. Okay, you will feel some shock because a capacitor stores charge. A capacitor stores static charge, and when you touch those wires, the charges find a way to go to the ground. They find a way to go to the ground. Charges flow from that capacitor to the ground through your body, as by using your body as a conductor, and it goes to the ground, and that's why you feel a shock. Okay, so what is a capacitor? First of all, it is a device that consists of two conductors. They may be charged or uncharged. We can charge a capacitor. Okay, it is a device that consists of two conductors placed uh, in specific position, placed in specific position with respect to each other. With respect to each other. Okay, with respect to each other. It is a device. It is such a device that it consists of two conductors. The conductors may be of any size, that doesn't matter, and they are placed in a specific position with respect to each other. They are placed in a specific position. Okay, now I see, yes, it is quite visible. These two conductors may carry different potentials and charges. These two conductors may be carrying different potentials and charges. Different potentials and charges. Okay, so it is such a system that it consists of two conductors placed in specific position with respect to each other, and these two conductors may be carrying different potential and charges. Okay, so before going to that thing, to the actual concept of capacitor, we shall be learning another concept, that is the capacitance of an isolated spherical conductor. Capacitance of an isolated spherical conductor. Why am I writing isolated? Because if I don't write isolated, the concept of writing isolated there is there. If it is your capacitor, there should not be any conductor placed nearby, so that it affects the storing capacity of this capacitor. Okay, that's why I am writing isolated spherical conductor. So if there is a spherical conductor, you can write like this: of radius r. You can write radius as like this, and is having charge q, and is having charge q on it. Okay, let if there be a spherical conductor. So what is the spherical conductor? This is one spherical conductor. The radius is small r, and q, it is charged with plus q, and you know that all the charges reside on the surface of the conductor. For a conductor, all the charges reside on the surface. Okay, for a conductor. So let the total charge amounts to some value, and that value is q. Okay, so you know that potential at the surface, as we have known from the previous classes, that is V is equal to 1 upon 4 pi epsilon naught q upon r. If you want to find potential on the surface, you shall be using this formula, that is V is equal to 1 upon 4 pi epsilon naught, the charge it has divided by the radius. Okay, now you have to find the capacity of this system. So as we know, continue from this point, as we know, C, what is C? Capacitance C is equal to Q upon V. Capacitance C is equal to Q upon V. So now write the formula, Q upon 1 upon 4 pi epsilon naught Q upon R. So you can see that from the denominator, these things go to the numerator, and Q get cancelled out. So what do you find? C is 4 pi epsilon naught R. The capacitance of a spherical conductor depends upon the radius of that conductor. Okay, that's capacitance of a spherical, isolated spherical conductor. This is your formula. It is an important formula. It is a very important formula. Okay, so the capacitance of the isolated system is 4 pi epsilon naught r, and you know the value of 4 pi epsilon naught. So at this point, 1 by 4 pi epsilon naught is equal to 9 into 10 raised to the power 9. Since it is at the numerator, you will be writing C is equal to, at this point, you will be writing R by 9 into 10 raised to the power 9 farad. For an isolated spherical conductor, the value of 4 pi epsilon naught is 1 by 9 into 10 raised to the power 9, and you see that C is equal to R upon 9 into 10 raised to the power 9 farad. So this is your formula for capacitance of an isolated spherical conductor. Okay, so likewise we can actually calculate the capacity of R, the charge storing capacity of R. We know, if we are a bit interested to find the charge storing capacity of R, so we can use this formula. So how are we going to calculate that thing? We are going to use this formula, that is C is equal to R upon 9 into 10 raised to the power 9 farad. Okay, for R, what is the radius of R? R is equal to 6400 kilometer. It is around this thing. Okay, it is 6400 kilometer. So now you have to convert this thing into meter, that is 6400 into 1000 meter, or 664 into 10 raised to the power 5 meter. And now you have to put this thing to find the capacity of R, that is R is equal, that is you put 64 into 10 raised to the power 5 in place of this point, 64 into 10 raised to the power 5 divided by 9 into 10 raised to the power 9 farad. So C is equal to, you can see that 64, it is generally 7 point, when you divide, it is 7.7 7.11, it is 7.11 into 10 raised to the power minus 4 farad. You can see that Earth is such a large object for us, and you can also see that its capacitance is very small. Its capacitance is pretty small. Okay, so for you should not think that 1 farad is small. Okay, you should not think that 1 farad is small. Let me give you another example. So you can be asked to find the capacitance of Earth. So you can actually calculate this thing, and for some instance, not for some instance, the capacity of Earth is like infinite. Okay, the capacity of Earth is like infinite. Any amount of charge can be given to Mother Earth, and any amount of charge can be drawn from Mother Earth. It doesn't affect the neutrality of our Earth surface. Okay, so the charge storing capacity of Mother Earth is infinite, but we have calculated the capacitance actually. So now let me give you another thing. From this formula, you know that C equal to R upon 9 into 10 raised to the power 9 farad. Okay. Let C is equal to, let we calculate 1 microfarad thing. We put 1 microfarad thing at the LHS. Let our capacitor is having the capacity of 1 microfarad. So we need to calculate the radius of that large isolated spherical conductor. Okay. So R 9 into 10 raised to the power 9. So what is your R? These things get multiplied. 1 microfarad, that is 10 raised to the power minus 6 into 9 into 10 raised to the power 9. These things, and it is in meter. You can actually see that 9 into 10 raised to the power 3 meter or 9 kilometer. So for a capacitor to get a storage of this much farad, it should be having a radius of 9 kilometer. That is a large thing to store. That is a large thing even to imagine, because a radius of, so we cannot be we cannot get more than this by naturally by using this theory. So we have to build something else, like you have heard about radios and transistor. So in this generation they haven't seen any such radios or transistor, because they were outdated by today's technology. So in like from 20 years from now, in case of India, okay, in case of India, so from 20 years from now, we used to listen the broadcast of any live cricket match by the help of radios, and those radios used to have this capacitor. Those radios or any electronic devices, not now, maximum electronic devices have been using these capacitors. Okay, so they have to store large charges. So for a 1 microfarad thing, you had to use such a big capacitor, which is not possible in this case. So we need to find the, or we need to build a good concept for the capacitor, and find good materials to reduce the size of capacitor and increase its capacitance. Okay, so let us now learn the concept of capacitor. So we have learned the definition of a capacitor. It is just a device that consists of two conductors. They are placed in specific positions with respect to each other, and they may be having different potentials and different charges. They may be charged up differently, and it is denoted by, they are denoted by, you can continue from this point, denoted by this thing, denoted by this thing. Okay, there are some two straight parallel line, and these are the connecting wires. This is a capacitor. Okay, denoted by this thing. Now we are going to learn the principle of what is its principle, what is its working principle, the working principle of a capacitor. So what is its working principle? So let us consider. So let me first draw you some diagrams and then I shall be writing the concept. So you can see that there are two parallel plates. These are two parallel plates or parallelly kept two conductors. One is positively charged. One is positively charged. This plate is positively charged, and the other plate is neutral. Okay, and the other plate is neutral. It is some at a distance apart. Okay, it is situated at some distance apart. Now what you do, you bring this plate closer to the charged plate. You bring this plate closer to the charged plate and stop at this point. You will see that due to induction, it is a positively charged side. You will see that negative charge will appear on the side that is closer to the charged conductor, and to maintain or to conserve neutrality, positive charge would appear on the farther side. On the further, same amount of positive charge will appear on the further side. So let us write this. Let this plate be A and this plate be B. Let us consider two plates, two conducting plates A and B. Okay, there are two conducting plates. A is positively charged. A is, this thing does not come in the exam, okay, but you need to understand the concept very clearly. A is positively charged and B is neutral. B is neutral. In the first case, this is the second case. Okay, let us draw some other thing. A is positively charged and B was neutral. It was some distance apart. Such that it doesn't affect the other plate. Now, when you brought the two plates closer, is neutral. Now, B is now we get B closer to A by induction. Negative charges appear on the closure side. So since you are just moving B closer to A, you will see that the closure side, the left side is the closure side, will be having negative charge. The negative charge will get induced on the closure side, and positive charges appear on the further side. Far further side. Okay, so you can see that since it is a positively charged system, it has a high potential. Now we bring the negatively charged system closer to it. You can actually see that this system and the negatively charged system tend to reduce the potential of the system. So as we know that C is equal to Q upon V. Now if this negatively charged is here, then it is reducing the potential of this system, and in the next case you can actually see that this positively charged side is increasing that potential. So in this case you can actually see, if there is only a negatively charged side, you can see that the V is decreasing, the potential is decreasing, and if V decreases, C increases, since they are inversely proportional to each other. If V decreases, C increases, and in the next case you will see that if the positively charged side is there also, then it is also increasing the potential of the system. So if V increases, C decreases. So what is good for us? We need to decrease V as we are going to increase the capacitance of the system. So we should be doing what? We should be doing the method, or we should be applying the methods to decrease the potential of this system. So the potential of the system decreases even if positive charge are there. Why? Because the negative charge is closer to the plate A as compared to the positive charge side. Okay, the positively charged side. So to eliminate this problem, we connect this side to earth. We connect this side to earth. This is earthing. We are doing the earthing thing. We are connecting this side to earth. That means the positively charged are cancelled by the electrons coming from earth. So this side gets neutral. So the right side, the further side gets neutral. So it is a conductor. The positively charged side remains the same. The negatively charged side remains the same, but the right side becomes neutral. But the right side becomes neutral by earthing, and as you can see, this negatively charged side reduces the potential of the system. Since V is reduced, capacitance increases. So I hope that you have understood the principle of capacitance, how we are, or capacitor, how we are able to increase the capacitance of a capacitor, or how we are able to decrease the capacitance of a capacitor. This is the only principle of a capacitor, and I have given you the definition, so no worries about that. So this is all about today's class. We shall be continuing more concept from tomorrow. So for today, I hope that you have understood these things, and if you have any doubts, you can ask me in the comments section. And I have also given my contact details in the description box. You can actually contact me there if you have any uh, problem regarding numericals of these chapters. So like our videos, subscribe to our channel, and share it among your friends who also need good education in physics. You will get more clarity here. So see you tomorrow. Thank you all.